The first lab is about connecting a standalone device, IoT device, Raspberry Pi, with a Node-RED interface to cloud. And we will use IBM Bluemix as a platform, and on IBM Bluemix we will use IBM Watson IoT boilerplate to create a Node-RED environment that will receive information from a standalone device. Imagine a situation when you are monitoring an installation, and this installation is really sensitive to the temperature. We will check the temperature. If something happens, then the standalone device will send information, and this information will be fed to our system. As soon as we get some data, we can also send this data over to Twitter to enable social-based information dissemination. So in this lab, we will start with accessing IBM Bluemix, which is a cloud platform. So after signing up, you can log into the platform, and then from the catalog you can find boilerplate which we are going to use, and in this case it's IoT boilerplate. After selecting the boilerplate, we can access it, and then just we need to type the name. Let's say for us it's 2016 Watson Developer Cloud. And my IoT. So let's create. After a few seconds we will be moved to our dashboard, and we will have some preliminary information about the platform. Now we will wait until the platform starts. If it doesn't start, you can restart it over here. If you have problem with restarting or starting, make sure that you have enough resources in terms of the memory or services being used. So this is our overview for the flows, the first flows that are default for this platform, and we are going to use the bottom one. So we have to configure the source from which we are going to get the data. So let's type ibm.b/IoT sensor, and it's going to create for us a simulated virtual sensor of temperature, humidity, and so on. So we need to copy this number that's going to be populated for the a unique sensor, and we are going to copy it over here. So after double clicking and pasting this data, we will start to get information from our sensor, and you can see immediately we are getting the temperature 16 degrees Celsius. So the next step is let's move it over here. We can increase or decrease the temperature. So if we reach temperature of more than 40 degrees, we will see the critical message. The temperature 41 degrees Celsius is critical, and that shows how fast and quickly you can set up the environment to trace on the cloud platform what is happening, and setting the threshold above 40, that's critical temperature. So let's say we are monitoring some valve, and then we can send information that and we can define the information for our purposes. So let's say it's not good that our let's say wine or some plants are exposed to high temperature. So let's type hello from IoT lab, and if we deploy this, we can start to see this message. So every time you change something, you have to redeploy it.
and now you can close some of the debug information. So now we will see just information about the critical temperature. So one of the things you can do, you can add, for example, Twitter as a mean of informing your social followers about what is happening. So over here we are just setting up the information about the dangerous or critical temperatures to our social media channel, and to authorize our channel, you simply click on the crayon over here. So just authorize your channel, and now you will be using Twitter to authorize the Node-RED to post information on the channel. So as soon as you save it and deploy it, you will be setting that information up to Twitter account, and we can go to my Twitter account, which is Bluemix, and you can see the temperature has been posted over here. So whoever finds such a message from time to time, you can know that I am doing the exercises. So let's remove it. We are not going to post it anymore. So now let's try to do something real. So let's SSH to our Raspberry Pi. So it's on local network created by my my phone, and now you can see that I am accessing my Raspberry Pi. And with Raspberry Pi you can launch or change the environment to do various things. And later on we are going to use this SSH connection to upgrade or add additional functionality to our Raspberry Pi. So this is one of the flows, just basic flow. We are injecting information. We are receiving a debug from static temperature, and we are sending it back to our IBM IoT platform. So let's try to set up our environment. So let's put over here our name that we are going unique name that we are going to use for the device quick start setup. So Bluemix 2016 IoT Lab 1, and we are going to use this name. So make sure it's a device and quick start selected. So as soon as we use it, we will be able to send information to this channel. And over here we just set up the static temperature, so nothing fancy. And we inject, whenever we click, we just inject, we start a new process, new flow, new instance of the flow. So now after deploying, we will be able to send our information. Let's clear the channel. So now we are injecting. So we are injecting, and we are getting the temperature. And on the side of the Bluemix, we are able to receive this information, but we need to set up our incoming IoT messages to Watson IoT platform. So let's put Bluemix as 2016 IoT Lab 1. So if we set it up and we once more inject the temperature, we should get it here. So temperature injected. And over here we receive the temperature. So now let's change the temperature. And let's put 42, which is a critical temperature. Let's deploy it. Okay, and now we are ready to, as soon as it's deployed, we are able to just get the information. So 42 deployed, and we receive it over here. So it's critical information, and that's more or less what we can do with static information. If you want to add a new functionality, for example, dynamic readouts from let's say some critical infrastructure, you can use this kind of the flow. So every minute or so you can trace information. So we are over here going to change the output IoT node to send the information to the new channel. So Bluemix S 2016 IoT Lab 1.1. And now we are getting the temperature from our sensor. This time it's we are getting the temperature directly from our internal CPU sensor. So we are getting temperature from Raspberry Pi. This is the command we are using to get the temperature. Okay, we can inject or we can wait. Every minute it sends the temperature. We can use it also just send whenever you want. So like now, it's set up only to send on request. So as soon as it's ready, we can inject the temperature. So let's see if the sensor, let's see if IoT platform is connected. It was connected. Let's copy over the channel through which we are sending the information. So it's Bluemix S 2016 IoT Lab 1.1, and as soon as we deploy, so let's deploy the data. Okay, it's deployed. So now we can send it from Raspberry Pi, from LIA sensor, checking the infrastructure, what is the temperature, and so on. So we got the temperature, and this temperature now it's being sent. As you hover around the text, it shows from which debug node the information was taken. And you see that the print temperature sent was delivered to Bluemix platform. And yet another temperature step that is going to be reflected in our platform.
In this step, we are going to add the new database schema to our Cloudant installation for Node-RED. So we are creating database temperatures in which we are going to store information about the temperature from the sensor. In order to store information about the temperature from the sensor, we need to add a function node and the Cloudant node. And we are going to use also debug node to just trace what we are having there. In the Cloudant node, we are going to store information in the temperatures, and it's going to be just insert field. And we are going to add message timestamp with the new date, just to have the information about the latest temperatures being inserted. So now we can see there are some, after deployment, there are some new temperatures being loaded. And now we can see through the query what is the latest document being inserted. So we are selecting by the field timestamp, a timestamp descending, and after launching the query we can see the documents. And here it comes, the document that is the latest one with the temperature 39 degrees. So now we can start our iOS app written in Swift. Let's call it check IoT temp, and we will store it in a directory. So I am adding myself as a developer if I want to install it for the device, but it's not necessary if you just want to work with the simulator. Over here we are installing pod init, and it installs the pod file. So we can now vim the file. We are uncommenting platforms, and we are adding one pod for the Swift Cloudant library. So Swift Cloudant, and after selecting escape key and then writing write quit, we can let it go. Pod install instruction allows us to see and download all the pods necessary, and now we can relaunch the environment. We are going to use the file Xcode Workspace, not as previously Xcode project. So Xcode Workspace. Make sure you are opening Xcode Workspace. Now we see pods, and you can see the pods are not being done. So Command B or just launching the application is going to build pods. Now we can start working with the app. So first thing first, what we need to do, we need to start working on our app. So this is our app. It's empty, so we are going to add a button for refreshing the state. So refresh IoT temperature. We are going to set it up according to the margins and leading points. So we are setting it centrally in the display. And in addition to that, we are going to add label, and in a label we are going to set the temperature. So we are changing the size and the position. Now we can set it up in the environment, so horizontally. Okay. Having this done, we can now reference the key, the button in the code. So refresh button pressed, connected, and we can add a simple log that the button was pressed. So refresh IoT temp button pressed. And over here we will get the temperature from the database, and we'll update the label. And to update the label, we need to also reference it in the code, so we are just going to add it here. And it's going to be temp label, and we are connecting. So we have this two lines, and now we can say the temperature in the label after pressing the button is anything we want. So temp label text equals temp equals question mark. So now we can test it if it works. If it succeeded, our environment started, so we can see, yeah. So this is what we wanted. We can now start building our code. So import Swift Cloudant. And now we can connect to Cloudant over here and find the object. Temp record, in fact, and finally we can get the temp value from JSON that we'll receive through the find query. Now we can start to implement. So we start with the Cloudant. In order to get into the database, we need to reference the connection credentials. So if we go to dashboard of the app and to connections, you can just copy over this part of the credentials. And so let me just copy it over here. You can use it. So it's a username, password, and URL. These parts we are going to use in our code. So first, let's add Cloudant URL. So the link we were copying before. Now we can set up Cloudant client. And of course, we need to import Swift Cloudant. So let's just add Cloudant URL over here. And now we can ask for a database. So it's temperatures. So with this, we are ready to call our database. So find document operation, and we are going to add fields. So database, payload timestamp, skip 0, sorting by timestamp, descending, and all defaults. Then we are going to start our response, HTTP info and error. And now we can see the results. So we are going to see the results. If there is no error, we can read the document. So let me go. Let me optimize the view. Now we can close the brackets and we can call the document. So Cloudant client add operation find, and probably we'll need to wait for the results from the database. We'll do it a little bit later on asynchronously. So when we refresh, we call, and we get the document, JSON response. So now we need to parse the JSON document. So we'll need this payload to be read and assigned to the value of the temp label. So now we need to go with the do catch clause, because we are going to do JSON serialization, and in a parsed document we will find the nested array, and we'll add error if we catch one. So now we can rerun our app. Okay, and now we see nested value. So now we are ready to get the nested values of temperature. So it's going to be a new document, nested array 0, a new doc. We should be able to get the to find the temperature over here. And we are going to call it with the backslash brackets. So we have 40. Now we have to reference this temperature in our code. So we found it. So we can clean the code over here. And we can add helper private variable. And it's going to be JSON temp. So self JSON temp equals current temperature. So of course it's double, so we need to use a double over here as well. And now we are able to wait for the value. So we are going to create the asynchronous wait for 1 second, and we are going to get the value here, which is just simple temp. Let go. Alright, and we need to just add remaining brackets. So now we are able to run. And if we refresh, we should get the temperature. That's all. Thank you very much for watching.